So first of all, and again I'm going to repeat it over here. Okay, so normal pH is about 7.4. And now we're talking about astrup, or blood gases. So what is the normal pCO2 in torrs, millimeters of mercury? How much is that? You should remember it's 40. This is very important. 40 is a normal amount. Okay, so then what is bicarb? What is the normal amount of bicarb? Like a day, 24 millimoles per liter. Okay, that's 24. Then pO2, all of you know it's about 100 or a bit below, but you can remember 100. And the last maybe that we should talk about a bit is the agap. Is the agap. And normally, if you use an older formula, it should be 12 millimoles per liter. And the formula is sodium minus chloride plus bicarb. But remember one important thing. 12 means if the albumin is normal. Okay, if albumin is not normal, you have to use a different formula, or you have to approximate it to different number. Okay, so but in case albumin is normal, then agap should be 12, about 12. And why is this? Why is this? Well, if I will remind you the ion columns, so there should be equilibrium between cations and anions, and the main cation is sodium. That one is 140, and the main anion is chloride, and bicarb follows. So this is 24, okay? And this is like 100, let's say, or 90. And the thing is, and I should have drawn it maybe better. Maybe I should draw it like this. Then there is the rest of cations like K plus whatever, and this over here is agap, and this is 12. Okay, yeah. And maybe you had already the osmolarity with me because I was talking about it a bit, but again, so look at this. The only thing which can really change fast is bicarb. And in case we're using this formula, we ignore this part in a way, okay? But it's really, you can forget that in a way, okay? So what do we have here? We have sodium, okay? Sodium, chloride, bicarb, and agap. And why is agap so important? Agap adds all the anions, the rest of the anions together. And the main representative of this is albumin, actually. It should be like 4. Okay? And that's why also if albumin changes over here, the whole thing changes. Okay? So that's why you first have to watch out about albumin. So before you use the formula for agap, you have to check albumin, that albumin is okay. Okay? But I don't want to go farther in details in this because you're going to learn this in the next seminar. But anyways, with this ion column, it's so great to to use it, and you can use it for many things, okay? And especially like for the pH changes, okay? So if you look at it, and I'll tell you that the bicarb is the only one that can really fast change. Then you can assume with changes of ions how the pH is going to be, because bicarb 24 means there is no metabolic change. There is no metabolic acidosis or alkalosis, okay? So look at this. If you're going to lose chloride, just chloride, what you're going to have, what will happen over here? What do you think? If you will lose this part over here, so it's going to be smaller. Yep. Chloride. So what will happen? The bicarb is going to expand. Okay, so you're going to have what? Metabolic alkalosis. Okay? Yep. If you're losing chloride, for example, by vomiting or suction of the gastric juice, they're going to have metabolic alkalosis. Okay? Yep. So, what if the sodium somehow is going to be increased? If you just look at this. So, if you expand sodium, the only way how to reach the equilibrium is to, again, expand, but you have to shift everything up over here. And again, you're going to have metabolic alkalosis, okay? Yep. If there's going to be, let's say, somehow buildup of chloride, you're going to compress the bicarbonate and you're going to have metabolic acidosis, okay? Yeah? Again? Yep, over here, if I'll do this now. So, if there's going to be more of chloride, this gets compressed and you're going to have metabolic acidosis, okay? Yep. And now the question with infusion of saline. How is it with saline? If you get infusion of saline, and it's answered in the videos before, but doesn't matter, once more. So if I give someone saline infusion, how this ends? Tell me, what is the logic behind it? So you're infusing a person with osmotically same infusion to the plasma, okay? The only way the saline is sort of physiological is in the osmolarity, but you're infusing sodium chloride in 1:1 ratio. And in this case, look, you have much more chloride than sodium. So anyway, over here you're adding just a small drop, but relatively you're like adding much more chloride to the sodium, okay, in contrast to sodium, okay, because sodium and chloride in the body are not in 1:1 ratio, okay, it's like 3:2 or something like that, okay, yep. So that's why theoretically you are adding with the saline infusion, you are adding much more chloride, get it? So it's the same situation as over here. So you're going to you expand the chloride more, and you're going to have metabolic acidosis. From today, then remember, every time you're giving someone infusion of saline, you are turning them acidic. Okay, please. So it's not physiological solution in terms of ABB. Okay? So you can play with these ion columns a lot, and it really helps you, especially in, let's say, changes of ions, okay? So, thanks for watching, and don't forget to subscribe and ring that bell. And as always, check the description below for supplementary questions and other materials.